Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to have a brief lecture on how we can plot a shear force diagram and bending moment diagram for a simply supported beam. Let's begin with the lecture. Today, as class assignment, we have assumed one of the most basic form of a simply supported beam. There is a beam with a span equal to L. There is a point load acting on the beam in the gravity direction. The magnitude of load has been considered as P. This load P is acting at a distance of A from the support which is on the left hand side, and at a distance C from the right hand side support. Now these values L, P, A, C will also act as variable for us, in which a user can input values and real-time shear force diagram values and bending moment diagram values can be calculated using the code that we are going to write today. So, as step number 1, we are going to import a few libraries. As I have told you already in the previous lectures, that Python has a huge number of libraries available. Each of those libraries can perform various tasks. Today we are going to use two similar libraries. One is called NumPy, NumPy, and which will be used for numerical calculations, and Matplotlib library, which will be used for creating plots. While importing the libraries, we can give them some nicknames, like I am using NP for NumPy and PLT for Matplotlib library. The syntax is appearing on the screen. At this stage, I don't believe that I need to explain the syntax. But still, if someone needs further explanation on syntax of any code portion, he or she can contact me. After importing these two libraries, there's some general information display for the program. Print simply supported beam. It's a simple print command that will print name of the program for the user information. After importing the libraries, we are going to start with data input section. The prime data values have been discussed in the second slide. We have discussed the full length of the beam as L, P as the point load acting somewhere along the length of the beam at a distance A from the left support. If this point A, P, is acting at a distance A from the left support, we can calculate its distance from the right support, which will be equal to length minus A. We have converted length, load, and its distance from default string format to floating decimal places. The benefit of using float will be the user will be able to input both values without decimal places and values with decimal places. After completing this data input section, we will proceed towards the next but very important point, and that is discretization of the x-axis. Whenever we plot graph along two axes, x and y, we assume a number of points along one of the axes, which is called independent axis. Usually x-axis is considered as independent axis. The values on y-axis are calculated using some relationship. And we also have a relationship for a simply supported beam where a point load is acting. So the extreme values of x-axis in this case will be 0, which is the starting point of beam, and L, which is equal to length of the beam, the full length of the beam. For instance, there is a beam of 10 meters. The values of x-axis will begin from 0 and go up to 10. To plot various points, we need to consider a number of points along the x-axis. For that, we have decided 1000 as the number of segments in which x-axis will be divided. So if 1000 is the total number of segments, span of each segment will be equal to length of the beam divided by number of segments. So we are going to use a function called arrange available in the library called NumPy, which has been nicknamed as NP. So np.arrange values starting from 0 going up to L plus delta underscore x, which is length of each increment calculated in the second step, and this is the interval between various points to be created using arrange function. So a number of points will be created with minimum value 0, maximum value 1 short of L plus delta underscore x. L plus delta underscore x marks the maximum value, maximum limit, but not including this itself. Delta underscore x is the interval. So a number of values will be created and stored in a variable called x. After creating variable x, I am going to create two more vectors v and m. The vectors v and m stand for shear force and bending moment. Both of them at this stage will carry only zeros. A number of zeros will be created. So the syntax is numpy.zeros. So numpy library will create zeros. How many zeros will be created? Like x. So the number of zeros stored in v and m will be equal to the number of values in x vector. Afterwards, we are going to calculate reactions R1 and R2. I'm not going to explain these formulae because you have studied these formulae for a long time now. So we are simply going to use the same formula to calculate R1 and R2, the reactions on left support and the right support. Afterwards, we are going to calculate shear force values and bending moment values. We have already stored zeros in the vector called v and m, but now we are going to replace those zeros with the real-time values. One of the benefits of storing those zeros is that if a value is somehow missed, 0 will already be available and it will help us in debugging. So I'm going to use for loop. Let me remind you, in second lecture I had told you that you were required to install Python on your computers. Moreover, you are required to perform some very basic calculations including for loop. So here we are going to use the same for loop. For I, unlike the previous languages where we were using for I is equal to 1 to 10, now we will say for I in range ln x, length of x. It means that for every value of x that will be stored in I, one by one. So if xi is less than a is the point where point load is acting. So the shear force value will be directly equal to the reaction, while bending moment value will be equal to reaction multiplied by xi, the distance. Similarly, if the values of xi goes beyond a, then the shear force value will be equal to reaction on the left hand support minus the load acting, or R2. You can write these values either in terms of R1 or R2. Again, I am not going to explain these formulae because these are the basic formulae used to calculate shear force diagram and bending moment diagram and have been taught in the class in the previous chapters. However, the important point is I have used if statement to calculate the values on the left hand side of A, the point of action of point load, and on the right hand side of the A, again the point of action of the point load, because on the left hand side and on the right hand side the formulae for shear and bending moment would change. So we have used an if statement for that purpose, and for loop will ensure that for every value of x a value of v and m will also be calculated. So after calculating these values, we can print the important points. For instance, I have tried to print by using formatted print command reaction on the left hand side support, reaction on the right hand side support, and maximum bending moment value M max. We have actually used tuples and lists during this code. I have not explained the complete description of these. However, we are going to study that in detail in the forthcoming lectures. This is the plotting sequence. It looks complex for the reason I have plotted a lot of separate individual lines. I have plotted a lot of text on the graph. Some portion is for shear force, some portion is for bending moment. However, in order to simplify the explanation, let me quickly share that two commands are very important. First command is matplot library. The nickname PLT was used for that, dot subplot. By subplot we mean that we are going to create several subplots on one figure. 2, 1, 1 means that 2 rows, 1 column. This is the division of subplots, that we have divided a figure into two portions vertically but one portion horizontally. Out of them, in the first portion we are going to plot x, v, which means shear force diagram values. Here you can see the same subplot command x, v. However, now we have also used R to give this line a red color. Line width is equal to 1.5. You can study these variations which can be created in plotting in detail. Plot.grid have been used to create grid on the plot, and then several lines have been created to show a horizontal axis, two vertical lines on the two edges of the plot. Title of the graph, shear force diagram with font size of 16, and some text have been shown that I am going to show you on the final plot. In the same way, the next step plot 2, 1, 2 have been plotted for x, m, which means bending moment diagram. Rest of the things are similar. I believe that if you study them in detail and try to type the code in practice yourself, it shall become easier for you. However, further explanation will be given in the next class. After those commands, plotting commands, plot.type_layout and plot.show can be used to plot these graphs and display on the Jupyter notebook. Tight layout will ensure that no overlapping will happen in between the elements, and plot.show will display the actual plot created. This is the final output that we are going to see. This red line that I am moving the cursor on is the actual plot that we have plotted by using x, v command. These are the three lines: horizontal axis, two vertical boundaries, 3.5 kilonewton and 1.5 kilonewton minus. These are the peak values of shear force diagram. Shear force diagram is the title. Similarly, bending moment diagram values and the graph have been plotted. To keep the time short, I'm going to end this lecture here. I tried to restrict the description within 15 minutes. After practicing that point load code, I would like you to rewrite the code for a beam subjected to UDL as shown in the figure. Do practice this. Make sure, please consider that in the next class we are going to practice this in the class as well, with some explanation for the previous code and this code as well. However, for greater clarification in the lecture, I would like you to try to practice the code yourself and bring your practice along with you in the next class. I wish the code shall be easier for you. See you guys in the next class. Allah Hafiz.